Okay, write the following expression as a sum or difference of logs. They want us to write as adding and subtracting logarithms, several logs, no powers. Okay, so and simplify your answer completely. So basically they want me to go log of whatever plus log of whatever minus log of whatever, That's how they want us to write it. It's one log. We're going to break it to be several logs added and subtracted. Okay, how do we do it? Well, we're using, again, the 3 log properties. So what are those 3 log properties? Here we are from the exam 3 notes, the 3 log properties. Multiplying for 1 log becomes adding for 2 logs. Notice when you go from 1 log to 2, 1 log to now 2, the operation gets easier, right? Multiplying becomes adding, which is easier. Adding and subtracting are the easy operations you don't learn when you were really young. Whereas multiplying and dividing, you learned a little bit later. Dividing for 1 log, it's a harder job for 1, becomes subtraction, easier for 2 logs. So again, easier for 2. Like a job is easier for 2 people than it is for 1 person. And multiplying is connected with adding because multiplying and adding make things bigger. Multiplying is repeated adding. And dividing is connected with subtraction because dividing and subtraction both make numbers smaller. Dividing is repeated subtraction. And then finally, powers. Powers can come to the front or back or power zone, back and forth. So power zone down to the front or front back to the power zone. It's all the same thing. That's the power property. Okay, well, let's use those. So here we go. First thing is I'm going to break this into several. This is z to the 11th plus log of w to the 14th minus log of the square root of x plus 9. We good so far? So we just have multiplying on the top. This multiplying becomes adding, which is easier, right? Because we're making it several logs now. So when you have lots of people on the job gets easier. Whereas we had 1 log here where things are harder. Harder job for 1 person, easier for 2. Then the dividing becomes subtraction, which again is easier. It's harder for 1 log. Dividing just becomes subtraction. Okay, so far so good. Now the powers come down to the front, don't they? You know about that. So grab this power, drop it down to the front, grab this power, drop it down to the front. So it'll be 11 log C plus 14 log W minus. Now, what about this guy? Well, what do we do with that? It's weird. This is the tricky part of this problem. What do you do with that weird square root thing? Well, here's a very, very important rule, which they're just beginning to dawn on us in this section. Here it is. So x to the a over b power is the bth root of x to the a. That sounds weird, the bth root. But there it is. Fractional. In fact, let me show the motion. Here, let me erase this. And let me show the motion here. That might help. See how this b can swing around and go into the hook right there? So the rule is this. Fraction powers are roots. They're one and the same. They're like saying one or uno. They're 2 languages that are saying the same thing, right? Say one or uno, you're saying the same number in 2 different languages. That's what's happening here. We're saying this and this are equal. They're the same thing in 2 different languages. There's the fraction power language. There's the root language. How does it work? The denominator, let me write it here. Denominator power swings around into the hook of the root. Right there. See what it did? See that denominator? The b is the denom, it's the bottom of the fraction, swung and ended up in the hook of the root. The x to the a is still x to the a. The top numerator power just stays. It's just sitting there. It's not doing anything, right? X to the a, x to the a. But the denominator swings around into the hook. That's an important rule to know if you're going to go forward in math and science to pre-calc and calc and stuff like that. That comes up more and more. So okay, so then let's use it on this problem. So therefore, this becomes x plus 9 to the 1/2. How did I come up with that? Let me write it down here. So I'll just say, so x to the 1/2 is the square root of x. How so? Well, right? See how that's a perfect application? Remember, this 2 swings around into the hook? And this can be written as just the square root of x. Why? Where'd the powers and stuff go? Well, that's all understood, isn't it? Right here, let me bring it down. I just don't have room here. Let me bring it down. This equals just the square root of x. Why? Because if you don't the 1 power is invisible, right? If you write no power on an x, you know it means 1. You don't have to write the 1 power, right? If I go x to the 1, that's the same as x. It's just a single x, right? First power. And likewise, did you know if you put nothing in the hook, there's an invisible 2. It's the only invisible 2 in math that I know of anyway. I don't know all of math, but that's the only one I've seen. So if you put nothing in the hook, like if we go square root of 9, what's the answer? 3. What did I just call it? Let me do that down here. Let me make sure this is clear. If I go square root of 9, let me just write out the word. Square root. What does that mean? What does square mean? What do you call this? X2'd? You call that x squared, don't you? So what does square mean? 2, doesn't it? What do you call this when you put a 3? X cubed. So cubed is a word for 3, squared is a word for 2. So when we call, okay, so what's my point? When we call this a square root, we're saying it's a 2 root. Where's the 2? It's really understood to be there. That's what I mean by there's an invisible 2. If you don't put anything in the hook, it's really an invisible 2. Why a 2? Well, why 2? Because you're saying the answer is 3. You're saying because 3 times itself twice is 9. That's the idea of the 2-ness, to use a weird word, the 2-ness of a square root. Do you see that? That makes sense? So if you put nothing in the hook, there's really an invisible 2 there. Just like if you put nothing on the power, there's an invisible 1 there. So what's my point? If you write square root of x to the 1, you can just write square root of x. The 2's understood, the 1's understood. So in other words, x to the 1/2 is just the square root of x. It's the same as a 1 in the power and a 2 in the hook, which is the same as a 1/2 power because the 2 swings around and goes in the hook. These 3 are all the same, aren't they? That's important that you know that going forward in math and science. Okay, so what? Well, so then we can let this 1/2 power float down, can't we? Because that is what they asked us to do. They said no powers and simplify as much as I can. So we're there. It's 11 log z plus 14. It looks like 141. Log w minus a 1/2. 1/2 goes in the front. Log of x plus 9. Right? Remember, powers come down to the front. So the trick is to realize that a square root is really a power. It's a fractional power. So a square root is a 1/2 power. Now you might wonder, where's the 1, Mr. Herring? Well, there's an invisible understood 1 already there, huh? Right? If we show no power, there's a 1. So there's where it is. It's invisibly there. So a square root on x is the same as x to the 1/2 power. So that's what you want to recognize. A square root on x is the same as x to the 1/2 power. Or a square root on x plus 9 is the same as x plus 9 to the 1/2 power. Because again, that 2 can swing around and go in the hook. It's the same thing. And then powers come down to the front of a log. So there is our final answer. I'm trying to box it so you can see it. Clearly, it's not easy to see. There it is. There is the answer to that question.